Oh, hello and welcome to Magic Theatre. We have a wonderful surprise for you tonight. We'll be discussing the physics of how awfully dreadful Indiana Jones and the Crystal Skull is.
What are you doing? We have to do the physics project. I thought you already started. It's due tomorrow.
Yeah, sorry, Lindsay. No? Yes.
Amateur.
Lindsay, you know what movie I absolutely loved? Indiana Jones and the Crystal Skull. It's just so good the way they have in the 50s and the communism and the Cold War and Shia LaBeouf with his hair.
No. All right, hold on. No. Shia LaBeouf spends half the movie brushing his beautiful hair.
So what? He probably needs to quaff his hair or something like that.
What? No, why would that be a character trait? That's just stupid.
Whatever. Also, I love that the aliens are really cool.
No, the aliens are the worst part. Like they're looking for the skull the whole time, and it's only magnetic when the plot needs it to be. What's up with that?
You know what? Whatever. Oh, you know what was really cool in the chase scene right before the ants with the boat car. What about? Yeah, they were really cool.
Oh my God, the monkeys are terrible CGI. Most of the movie is terrible CGI. I don't know what you're talking about.
You know, whatever. I love the movie. You can say what you want, but I still enjoy the movie and I watch it all the time.
No. Come on, Chloe. We're gonna show them the Cinema Sins video.
Oh, you know what? Whatever. Fine.
These crowbars amusingly stick to the metal container right after they open the crate, but if this alien box is as magnetized as they say, they should have had trouble before that. What? Now the metal light fixtures are affected by the box? Because the plywood shipping crate was dense enough to keep the magnets from being strong enough before? Mutt combs his hair in this movie so many times the continuity person on this movie started to lose track. Man, so much bullshit just happened, I think the dinger might have broken.
There.
Okay, fine. I kind of have to agree with you there. But the only thing that really stuck out to me was the fact that Indiana Jones miraculously survived a nuclear test in a refrigerator.
That's the only thing you have a problem with.
Yeah, only thing.
Nothing stuck out to you besides that.
Nope, no.
Not how they plummeted off of a waterfall that was bigger than Niagara Falls and were not injured at all.
Okay, fine.
How about how he was inside a rocket car with no seatbelts or anything, and when he stopped, he didn't fly off of it? Inertia!
Physics project.
Yeah!
Problem with Indiana Jones and the Kingdom of the Crystal Skull is how the heck is Indiana Jones going to survive a nuclear blast from inside a refrigerator? As soon as Indiana Jones hears the atom bomb alarm, he quickly dashes inside a refrigerator, knowing that it will keep him safe. But will it? Using data from a real-life example, the atom bomb detonated at Nagasaki produced 59 to 79 kilopascals of energy. This is enough to vaporize anyone remotely close to the blast. Roll the clip.
9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
First off, we have to talk about overpressure. Overpressure is the pressure caused by a shock wave over and above normal atmospheric pressure. It most commonly occurs after large explosions, such as the one Indiana Jones encounters. Real-world data from the bombs exploded at Hiroshima and Nagasaki shows that, at the epicenter, overpressure reached over 138 kilopascals. What does this mean? Well, pascals are measures of pressure. At 22 kilopascals, eardrums rupture. At 68.9 kilopascals, lung damage occurs. At 69 kilopascals, all building structures are destroyed. If the location Indy was at reached 138 kilopascals, there's no way Indiana would have been able to waltz out of the refrigerator with no injuries. And that's not even considering the force exerted on him when he rapidly accelerates due to the blast, or the force of impact on him when he hits the ground. He should have been an Indiana Jones milkshake. Also, do you see how close to the mushroom cloud he is when he gets up? Indy and that prairie dog are going to have to deal with some serious health problems later on due to radiation.
Second problem of Indiana Jones and the Crystal Skull is a classic scene in which Indiana Jones and a Russian officer have a tussle and end up on a rocket car. It's physically impossible that they could have survived the rocket car unscathed. Roll the clip.
To understand Indy's ride on the rocket car, we will use actual data created by Colonel John Stapp. In 1948, Colonel Stapp conducted rocket car tests that resembled the one seen in Indiana Jones. In one of the tests, the rocket car accelerated to a speed of 632 miles per hour, or 282.53 meters per second, in a matter of 5 seconds. The force created from this rapid acceleration would have been 4,874.25 newtons. On the deceleration, the car went from 632 miles per hour to 0 in a matter of 1.4 seconds. This would generate 17,410.15 newtons. The forces created gave Colonel Stapp injuries such as broken limbs, broken ribs, detached retinas, and other various traumas. The forces created gave Colonel Stapp injuries such as broken limbs, broken ribs, detached retinas, and other various traumas. The only injuries Indiana Jones and the Russian officer obtained were unconsciousness and disorientation. And are we just going to ignore the fact that, despite having no seatbelts, Indy and the officer somehow defy physics by not flying off of the rocket car after stopping in such a short amount of time? Inertia should have kicked in and propelled them forward. Thus, the unreliable, poor physics of Indiana Jones and the Kingdom of the Crystal Skull is exemplified further.
Third problem, Indiana Jones and friends plummet from a waterfall that is 110 stories approximately. Roll clip.
You okay? Babe.
Indiana Jones and friends think they have escaped the Russians until they come across a series of 3 waterfalls, each bigger than the last. Could they have survived going over the falls? To test this, real-world data is once again needed. The movie was filmed in Brazil, and the tallest waterfall there is 340 meters tall. By using the law of conservation of momentum, it can be calculated that the boat is traveling 258.15 meters per second from the second the boat starts to plummet to the moment just before hitting the water. Set the potential energy at the top of the waterfall to equal the kinetic energy at the surface of the water and solve for velocity. To find the force exerted on each person, use Vf squared equals Vi squared plus 2AD. Final velocity is 0, and initial velocity is from the previous problem, 258.15 meters per second. Distance would be 4 meters down. The acceleration is negative 8,330.18 meters per second squared. For force, use force equals mass times acceleration. The average adult woman is 76.90 kilograms, and an average adult man is 86.27 kilograms. The force on a woman would be negative 640,577 newtons, and the force on a man would be negative 718,644.63 newtons. To put this in perspective, the average human bone breaks at 84,000 newtons. This data makes the whole scene very unrealistic, especially since after the fall, the heroes were sitting on the beach unscathed.
This is Lindsay Walsh, and you just learned physics. This is Lindsay Walsh, and you just learned physics.
This is Zach Chanley, and you just learned physics. This is Zach Chanley, and you just learned physics. This is Zach Chanley, and you learned physics. I'm done.